So I'm Gus Heck. You'll see Patrick as well on official things. That's as I've done this for a while. And I am founder and chief architect at Needham Software LLC. And Dave?
I'm Dave Smiley, Lucene Solar committer. I do freelance consulting, although I recently just joined Salesforce. And one of my claims to fame is I co-authored the first book of Solar Enterprise Search Server.
I also want to mention a guy by the name of Dave Mackay. The technology I'm going to show you today was developed in a project that was to develop a coaching platform. That was his vision and his idea, and then I developed technology to make it work. I wanted to say that it did all work in the end, but unfortunately we did not get funding, so it does not exist anymore. The name of the company was Simply Coached, and it was an online career coaching system. And one of several key goals was to identify topics the user is interested in learning. And we're trying to do it by learning through their click-throughs. So learning what interests the user based on their behavior on a per-user basis. We also want to be able to make predictions about what they're like based on the entire user base, because when you onboard a new user, you don't have any data about their behavior, so you need something to predict with. So you got to be able to do it more than one way. Another problem we were worried about is the calcification of the model. You build a model predicting what the user likes, and since this is a learning platform, hopefully they're going to learn something. So once you've given them several articles on how to make a better TPS cover sheet, they may have learned how to make a TPS cover sheet. They may no longer be interested in it, so you have to move forward, and what's relevant changes. When we started this venture, it was back in 2016, and the third wave of neural networks was, rising to a crest at that point. Everybody was really excited, so of course we looked at neural networks. But for this project, they didn't seem to be a good fit. They're not so good at adapting to a changing problem, and you'd have to retrain them over and over again. And training neural networks, as you probably heard Kevin Waters say in his speech, takes a lot of effort. And retraining them over and over again was not going to be a good option. So then we look at regression models for prediction. And this is better because they actually can converge faster and become useful with less data, so it's easier to get them retrained on a regular basis. But a lot of them, if you saw Joel's talk, it's very important that you have normally distributed residuals and heteroscedasticity and some other constraints like that. A lot of the stuff we wanted to use as features was binary presence or absence of a tag. Binary data is not going to work out well for normality. So I'm a little bit of a stickler for not violating the assumptions. Some people sometimes take the linear regression models and just apply them anyway, and that sometimes kind of works, but I'm sort of a stickler for not violating the assumptions. So I went looking for a non-parametric regression technique. What I found was non-parametric multiplicative regression. And that's something that's used in habitat ecology for predicting habitat suitability. I did not manage to get permission to show it, but there's a nice diagram that I would like to have shown. It's a map of the range of the western larch. And they use this system to predict the range based on several features such as the average temperature in a year and moisture and things like that. And it predicted stuff, and that lines up very nicely with the known range map, except for two places where it actually predicted trees, but it wasn't part of the known range. And when they went to those places, they found the tree was actually growing there, even though they didn't know it. So it was very good in habitat ecology. It can make a prediction that outputs a continuous value, so that's good for sorting and ranking. And kernels for presence and absence are well known in that, so I didn't have to invent that. I actually tweaked them a little bit. And another nice thing is that it breaks down into discrete subcalculations pretty nicely. And so equations look like this. It's performance across multiple features. This is the overall equation. And you see the little w in there? That can be different for each feature. So you get continuous features. You get something that's essentially a normal curve. And things that are in presence and absence, you can use a 1 or a 0. That's actually what I tweaked. I used a 0.9 or a 1 because I didn't want to totally eliminate something if there was just one missing match. Because 0 times anything is 0, and then you're done. This product and this sum can be pre-calculated on a per-user basis. And I used that trick to make the predictions on both the full user set and the individual users. I call these pre-calculated things partials. I'm not really talking about the mathematical concept. That's, if you hear me say partial, I mean these things. But of course, the question is, what are we predicting? We need a variable to predict. And so, of course, we want to know what the user is interested in based on what they've clicked through previously. So I had to come up with some way of measuring that. And my idea was that if you present with good teasers and maybe an image, the things that are of interest to the user, they'll look at it and go, oh, that, click. And if you get a list of things that are less interesting, like, well, maybe that. And if there's nothing interesting, they'll browse away and never click. And so I figured I could use that, hopefully, and it seemed to work, in order to predict reaction time to the presented results. So I'm going to demonstrate a system doing this. I built a little demo system that took some parts from Simply Coached and rejiggered them to predict images that people will like. And I created 3 users. User 1 is Sporty Black, user 2 is Cooper Blue, and user 3 is Racy Yellow, and they like black sports cars, blue coupes, and yellow formula cars, respectively. I trained this system by presenting to myself, as each user, sets of 9 cars, and then clicking on one, and if I got something that was really right in what they like, I clicked quickly, and if I got things that were only sort of there, I clicked slower, and if none of them were very good, I just took forever to click. And so I obviously made that part of the assumption work. And we want, oh, it's not showing me on the, there we go. All right. And I need to get out of presenting mode so I can see this. Well, okay, maybe I can see what I'm doing here. So right now you're seeing predictions for Sporty Black, and you notice they're almost all black sports cars. And the resolution's gone down again. There you go. If I can mouse while looking sideways, we'll get ask the system for predictions for Cooper Blue, and I get blue coupes. These images are labeled with tags of what type of car they are and what color they are, and so it's using that to find the images. And yellow race cars. So the interesting thing about this one is there weren't so many of these in the database, so not everything is a perfect match. You have a yellow sports car. It's not a formula car. You have a formula car that's not yellow, but it's still prioritizing them based on the proper tags. So it's working.
You can scroll to the bottom.
Oh yeah. So Dave's reminding me, I want to show that you have the click data, which I spent some time making available on this page to show you. And what you can see here is I have here something that wasn't at all like it. I took 30 seconds to click on it. This is the yellow formula car. I clicked on it in 1 second, and this sports car in 5 seconds because it was yellow. All right. So how did I do it? Well, in the back end, this is doing streaming expressions. This big monster was what we used in Simply Coached. And there were as I said, there were other things going into what we were trying to suggest to the users besides what I'm showing you today. Today, what you're seeing is, use the pointer, is this part up here, this little query here, and a hash join. And so that looks like this. And this is a lot of small text on a big screen. Probably hard for you to see, but the thing I'll point out is that here you have a data source, which is we're searching a time-routed alias, which Dave will be telling you about momentarily. It's filtered for user 4, which was Racy Yellow. And over here we have a search against the static information about the race cars. So it's taking the prediction, matching it up with race cars from another index, and then off we go, and the UI asks for the right URL. So, thing to notice about that, when you look at this section here, zooming in, you see this, and it's the TRA. Another thing to notice is this part right here. We're doing a division at query time to complete the model, which is this division here. So, had to get all the data in there, so I used a gestion framework that I wrote called GesterJ. It's an open source project available at gesterj.org. And it supports full DAGs, so that had some nice things because you could query the users once and have 2 results. Here, these 2 streams put in the static data about users and race cars. That doesn't change very often. The interaction data is here, and that goes into the time-routed alias. And this here actually invokes an update expression in streaming API to make those partial sums out of the interaction data. So I have a streaming expression that does that calculation as well. So you can see it's working. It's nice in a toy example, but can you scale it? Will it work in the real world? Unfortunately, SimplyCoach never got to really grow fully, so I can give you an answer that seemed to work and some reasoning why I think it will work. Also, sorry, I skipped over. You can also adapt with other types of metadata. I'm putting in users and time. You could have other types of metadata attached to these equations with this technique. So the 4 dimensions you have to scale across are the content you're recommending. This wasn't so scary to us because it was a curated set of content. We had control over the size of that, so we can make it work. And we were expecting to be able to handle about somewhere around 10,000 pieces of content without really blowing ourselves out of the water. The users, we were going to price it per user, so that drops out from a financial perspective. And you can ignore that because every time you get a new user, you're going to pay for it. So you can afford the hardware. The activity of the users is the thing that's sort of uncontrolled. And it is the case that if you improved your UI and they suddenly started using your system a lot more, you would actually need more resources to handle this. But we felt having one thing to account for like that is okay. And the next problem we run into is that because you're continually collecting this data over time, your indexes are getting bigger and bigger and bigger. And if you don't do anything, the queries are going to get slower and slower and slower. So you have to deal with the time series data in a way that makes sense. And time-routed aliases are a great solution for that. So here's Dave to tell you about time-routed aliases.
Hi. Can I have the clicker? Yep. Hi. So the diversity of use cases across solar is very interesting. So here we have a case of time series data. It's not logs that I'll tell you about in a second. It's click data, but it's event and it's time-based, and we want it to decay out of the system. There's potentially a lot of it in a system that would scale. So we're going to segue from the first part of the topic to a rather different topic called time-routed aliases, a new feature in Solar. Before getting right to TRAs, I'm going to have a little conversation about logs. Time-stamped data, I should say. Logs is just one of the things that we can put in Solar that's time-stamped. Could be sensor data or social media posts. I've seen these cases, or click data, user behavior. There's plenty of cases for time series data. So I'm going to tell you a little bit about how to put this data in Solar, how you could do it, different ways to do it, and some pros and cons. And then that will lead up to TRAs. So the characteristics of this timestamp data is you have a lot of it continuously flowing in and limited retention. If you have a case where you don't really have that much data, but it is log data, then maybe it's not a big problem. You can kind of do the default way that you might put stuff in Solar and not think about it. But if you really have a lot of it, and if it's time-oriented, and especially if you need to decay it, you might need to think more about how we put it in Solar in a way that makes sense. Oh, click the wrong button. Okay. So there are several strategies to put it into Solar. One is hash partitioned. I'm going to get into each of these in some detail. I'm just giving a summary right now. So with hash partitioned, we have one solar cloud collection, and the documents are dispersed. I keep wanting to say randomly. It's not random, but it's effectively evenly distributed amongst all the shards in the collection. And that's built in and nice. Or you could try and do it in a time-oriented way, which is to say, whether you have one collection or whether you have multiple collections, as you get to each new segment in time, you create a new partition. And I'm using the word partition here, partitioned, routed, organized in a semi, like the same thing. I mean these in the same way. Sometimes I use one word or the other depending on the slide or context where I felt one word was better. Some of these are built in and easy. Some of these are more roll up your sleeves and do it yourself. TRA's new feature is built in. So that first choice, this is an easy choice. And if you don't have a lot of data, you very well might just do this. You'd simply throw the data into Solar using a default kind of setup that you'll generally get the composite ID router if you have a number of shards. And it's easy. And one nice benefit that you get from this strategy is that the write throughput is really high. You can shove lots of data in here really fast because the data is streamed out to all these different shards. So if you're thinking about how many shards you need, and if you really think it's a dozen or so, then your data is going to be streaming into 12 of these shards at the same time. Great. So what's wrong? Well, if you need to decay, if you don't need to have retention of your data forever, if it needs to phase out, well, then you need to start deleting it, and that creates dead weight. On the screen, I did that here with some red. And that dead weight, it adds some cost to your queries and indexing that's happening in the background. Also, this is inflexible. I mean, maybe this is the right shard number right now. If your things change, then maybe you wish you had a larger number. So then you're in an awkward position where do you start over? Do you re-index everything into a new one? It's hard to, it's not dynamic in terms of the sizing. And with data at the scale, inflexibility and performance is kind of a corollary for cost. These things are, at this scale, this means it's expensive. So you could very well go to this in production if you had an unlimited budget, then get some awesome hardware, and you could proceed with this. But it's nice to take advantage of the aspect of how we, the fact that we don't need to keep these documents forever. We can put it in Solar in a smarter way that makes better use of the hardware. So we should time partition this data. And here I'm talking in general terms. I'm not talking about a specific way to do it. We could, I'll get into in a second, that we could use, there's a couple ways to do it, TRAs being one. But broadly, we're putting the data into, I'll just use a general word, partition here. And these are time-oriented partitions. And on the screen, we notionally have a year and a month, but you can imagine that's kind of whatever date whatever unit interval that suits you. So the data will always go to the latest one, and you always drop the last when you don't need it anymore. It's pretty nice. You could do a variable sizing. As you see right here, it's strictly time-oriented, so the data may not be, if you tend to have a lot more or a lot less, depending on the month in this case, then we see unequal sizing, which is not necessarily great. It's better to have more equal size, but this is kind of up to you. The negatives I listed on the previous slide about hash routing are largely addressed. The write throughput, one of the positives of the hash routing approach is that the write throughput is awesome because your data is going across all your shards. Here, it would seem that is a problem. It really depends on if that partition, for example, is a collection and that collection has a number of shards, then you can largely address that by having each of those partitions be a collection of num shards equals 4 or something, whatever suits you. Another advantage here is that one of the negatives I listed about hash routing is that it can be hard to address a real-time search requirement because Solar's caches, which help make it fast, are largely become ineffective across all of the shards, because data is going to all of them, and commits are happening across all of them. If you only have your new data going into one, it's a more tractable problem. You could put the latest partition could be on the latest and greatest hardware, so you could address it by making the first box a better box. It just becomes a more tractable problem. I want to point out why the previous partitions can be potentially optimized, which is a Solar command you can do to merge the indices. It's flexible. It's more flexible. If you want to keep more data, no problem. Just as long as you have the hardware for it, no big deal. You don't need to start over. So, how do we do this? This approach makes sense. You could have one collection, and using the so-called implicit router, bad name, a lot of people know that, but it's basically a do-it-yourself mode where you create the shards on, when you need to, and you put the data in the right shard. I have a link there to some code that I wrote. It's part of another project called the Harvard CGA BOP project, where I wrote a component or two within Solar. There was an ERP to route some data on indexing, and there was when queries came in with certain patterns, I would query the right shards. So you could take that up if you like. Originally, I felt like this approach makes sense. It kind of logically makes sense in the sense that I have one set of data fitting into one collection. Kind of made sense, but I largely became convinced that it's better to have multiple collections instead of where each partition is a collection, instead of having one collection where each partition is a shard, because you have more flexibility, and that, in other words, new collections that you create could have a different configuration than the one before. Maybe you need more shards. You have more flexibility with the number of shards per partition there if each one of those partitions is a collection. If each one of those partitions is a shard, you can't vary. Your hands are tied in many ways. And it may not matter to you, but once you start getting to a lot of data, you want this flexibility. It matters. So there's a great blog post by Mark Miller about this. Wrote it some number of years ago about how you can do this using an alias and a bunch of other code on your side when you feed data to Solar. It's very nice. And recently, with Gus here, we worked on time-routed aliases, which is a new feature in Solar that does this directly. So first about collection aliases. So in Solar Cloud, we've got collections, and you can have aliases, which are simply another name for a collection or a list of collections. Some people don't know that you can have aliases pointing to more than one collection, but you can. You can even have aliases pointing to another alias pointing to a collection. It's not fully recursive. It's only one level you can do that. So this is useful. Right, in this example right here, we have this theoretical TRA demo pointing to 3 collections listed and ... to some more. It's a very simple mechanism in Solar. It's just a list. And all the nodes know about the aliases and know how it resolves. So internally, it takes that name, whatever the name is, and it resolves it to the actual list of underlying collections, and then it hands on as normal. So time-routed aliases is conceived as an alias, a special alias with some extra stuff. It's still an alias, but with some new tricks. So now aliases have metadata, because we need to store this information about the TRA, like we need to store information about what is the configuration of the new collections, for example. What is the interval? How long do we need to keep the data? There's metadata we need to store. So aliases have metadata, and you can read and edit that metadata. And collections that are a member of a TRA know that they are a member of a TRA at a particular juncture. There's an internal mechanism in Solar's architecture called an update request processor. There's one that gets registered automatically for TRA, and it will do routing decisions. A document coming into any of these collections will recognize where that document goes. If it's not the current collection, it will ensure that it gets sent off to the right one. And it will automatically create new collections on demand as data comes in. And it will automatically delete the oldest collection, assuming, of course, you've configured it to do so. This is data-driven, which is nice, because if you leave the system at rest, don't send data to it, it's not going to go off doing anything. once you start adding data to the latest collection, it's going to start realizing what it needs to do on demand. And just about almost all of the configuration is mutable. You could change it later if you realize you need a higher num shards on your newest collections, and you can do that. Up here on the screen, we have an example of how to tell Solr to create a TRA. On this slide, I chose to use the V2 API, which doesn't get enough press. I could have used the more classic API. Would be admittedly shorter, which is nice, but here it's a bit more expressive. So the URL here is APIs. That /API means it's the V2 API to Solr collections. And then we have some JSON. So this command is a JSON command to Solr. And we have a create alias command. We have the name of that alias. And the unique things that makes this a time-routed alias instead of just a plain alias is the existence of this router. And this is really a sub-hash of settings. So we have, it's a time router. It's going to route based on a certain field. When we create this time-routed alias, it needs to know the very first one. What is the interval? In other words, how often is it going to be creating these? And what is the retention age? And there's the settings for when it does need to create a collection, it needs to know what the config is to create that collection. So there it is. The example here, by the way, with underscore default is fine for a demo, but in the real world, you're going to create the config set and refer to it by name. So there's some fine print here. It was introduced in 7.3. It's been improved incrementally in, I think, just about each version since. Some of the to-dos are, it'd be really nice if it was size capped instead of time capped right now, because of course data can flow in unevenly, and it's nice to have to not have so much hotspots that can develop if you do have it time partitioned. Once you start putting data in this time-oriented way, it's kind of obvious, like, hey, when we issue searches that have a time filter, I mean, gosh, we shouldn't send it to every collection, only the suitable ones. So that's an obvious one. It's something you can do yourself if you want to query this data set. You can certainly list the collections in your query to Solr. Obviously, Solr should do it as well. It shouldn't be a hard feature, but maybe some question about how will it detect it. So we'll see. I think TRAs beg for integration with autoscaling. Because if you're working with data at the scale, you're going to want to use Solr's cool features about that autoscaling. So it would be nice if autoscaling knew about the latest collection, and maybe you want the latest stuff to be on the latest certain hardware that you know to be better. That would be cool. And that auto merging of segments, which is called optimize, that would be cool too. And it's a little pain right now to delete the TRAs. It should be user-friendly. So TRAs may not be for everyone, even though you met the use cases up front, lots of data, time-oriented, et cetera. There's some aspects that are rather opinionated about it internally. The main thing is that the partitioning is very strict. It's time-bucketed, and it wouldn't work well if your data is going to flow in with seemingly random dates from the end of eternity. It's very strict in terms of every collection needs to be contiguous between your beginning and your end. It's not going to randomly create them. Realistically, I think that's fine, but people have interesting use cases. And when someone on the Solr user list pointed out that it doesn't work with CDCR, it'd be nice if it did. Maybe it'll happen. So I should do a quick little demo. Okay, I'm going to switch to Chrome, and you said right here? Yeah, please do. Okay. And this is just Solr's admin screen, of course. And if this is going to be a real challenge to demo up here.
We could probably kill the presentation at this point.
Yeah, can you do that?
Make it easier for you.
Did you do mirror mode?
Yeah, I didn't.
Is that it? Mirror mode? Look at it. It had it right there. Yeah. Okay, and show. Cool. Okay. Let's bring up Chrome, and now we can see the. Okay. Yay. And we have some commands that we're going to send to Solar. And we have a terminal prompt right over here. And I'm going to go to the, this is the same command that we had up on the screen. I'm going to create the TRA. Let's give this a shot. This will better work. Yep. Okay. So if I go over here, I hit reload. There it is. We have TRA demo. Let me zoom in. Let me try and zoom in on that a bit. We have TRA demo. It has a 2018-0101, and this has 2 shards. So now I'm going to switch over and add. I'm going to add a couple documents. I'm just going to add 2 right now. I don't know, 1 at a time, no problem. I'm only going to add a few documents to illustrate the point here, 3 or 4 documents. Let's add a document. And if I go over here, I can query it. Right, there's my 1 document. And this document had January 1st, noon in it. And the next document, this is a daily interval time-routed alias. So if I now add a document for that's the 2nd of January, copy it. This should create yet another one on the fly. I waited for a moment when I added that document. That's because the simplified config I did here will create them on demand, not preemptively. So the TRAs can create the next collection, can be configured to create the next collection preemptively, which is to say that as the data is added near the end of the time window, it will create that next collection in advance, given enough time. That way there's no hiccup as you're adding the data. There's no, So here now we see the 2 collections. I'm going to add 1 more quickly. And the more interesting part is when I get to the 4th, because we have a retention set on this. Right now I should see 3. Good, I see 3. 3 documents, a collection for each document. We've definitely oversubscribed our hardware for this data set. And let's add the 4th. So this, we have a retention set. So this is going to cause the oldest one to go away. So 2018-0101 is about to disappear shortly, soon after this new one gets added. Yep, we see the 2nd, the 3rd, and 4th. The 1st is now gone. So instead of seeing 4 documents, we still see 3 because the first one's gone. So pretty straightforward idea. I could have had a streaming code of stuff flowing in all the time, but then you don't see the actual data. So that is about it. I realize it's a very split talk, so we had 2 topics you can ask questions about. So that's the end of our presentation, and questions.
So, like you're doing it at 1 per day. So for a year, you could, like if you put in a day from a year ago, would it just generate all 306 however many collections to fill in the gaps?
When you say a year ago, like in the past, so at the time that you create the TRA, you create the first one, and you cannot add data prior to the first one. If you try and add data prior to the oldest collection, you will get an error for that. I think that may be configurable. You may get there's ways of ignoring that.
And if you go the other way, a year in the future,
It's going to iteratively. So good point. Very good question. So you wouldn't want to like what if I add the year 2050 or whatever? You don't want it to iterate into forever. There's a safety net in place such that you can say that if the data is added and the time on the document is more than, by default, I think it's 10 minutes ahead of the current time, the now, I think it's the now time, or the latest collection time.
What the next one?
Yeah, it takes the latest collection time, and if it's too far by your configuration choice that's changeable ahead of now, you'll get an error, and perhaps potentially it's your bad data. But as long as it's not too far ahead, it will iteratively create the next and create the next until it finally can put it somewhere. In a normal mode of operation, hopefully you'd probably enable preemptive creation, and things will probably flow in gracefully, and it'll create it in advance. But I can admit there could be use cases where that's not necessarily always true. Like for example, if you have backup data that you need to replay for some reason, perhaps not. Way in the back, Noble? No, this is someone else.
Can't this cause the problem that certain charts become too hot, like the most recent one, because all the queries are hitting that one?
Yeah. So if your queries are such that you're always querying the latest data, the idea in this design is that you could put the latest collection on the latest hardware, and by put it there, I mean so. These things got automatically created, and Solar Cloud put it wherever. On this laptop, there's only one node. The idea is that you would either. I think there's begging for more auto-scaling integration, where it would know it's the latest and put it on some particular machine of your choice. That's definitely out of scope than what I did here. What I did here is just a matter of is it creating it automatically. So you can. I think the current. Auto-scaling is new, but I think there's the current so-called snitches in Solar, where you can add hints to new collections being created. So I think what you could do is when it creates, you could, in the configuration for the collection, you can give it I forget if it's a snitch or whatever it's called, you can say that a flag of sorts. And so that when Solar Cloud provisions that collection, says, oh, I need to put you here. And so there's more do-it-yourself work in terms of placement and scaling. So what's not do-it-yourself, what Solar is doing built in here is this creating stuff for you. What's do-it-yourself, admittedly, right now, is making those kind of operational hardware choices of, where do I want it to live? That it's not doing automatically. But I would like to hear, it's a new feature. I'm hoping to hear from people actually using it and saying, here's how we made it do this, or we couldn't make it do this, and then we can scratch our heads and try and address it.
The creation of the collection, you have all the options that are normal for collection creation. So all the options you normally have, you can specify those in the configuration for the TRA. So anything you can do with a regular collection, you can do with the sub-collections of the TRA.
I should say I have seen a design that I think was rather nice for. I think it's Rokana did a talk a few revolutions ago, where their strategy. It could have used this, but at a higher level strategy, they had, theoretically, if TRAs existed, one approach to this is to have the latest 30 days. Let's just say the last 30 days, people are searching for that all the time. You could have one TRA or just a regular Solar Cloud collection, despite the fact that it's got some of those negatives. But if it's only 30 days, you could provision that, put it on some awesome hardware. It's always fast, but it's only 30 days. And then you also send the data to your long term. So if you have this very bimodal where it's like, oh, it's recent, it's super fast, and recent is 30 days. And if it's a long-term query, okay, we don't have to worry about your query can take a second. Then you can provision it twice, assuming you're willing to pay for that hardware. So time is up, and feel free to ask me questions at the end. Thank you.